Hi, welcome to another junior trigonometry video. In this video, we're going to focus on trigonometry and bearings. Now, if you can recall, a bearing is an angle that is between 0, 0 degrees and 360 degrees. It must have 3 digits, which means an angle of 47 is written as 047 degrees, and it's measured clockwise from north. All right, we've got two examples to explore, so let's get into example 1. A plane travels 130 kilometers between town A and town B. So I'm going to draw a diagram to help me get my head into this problem. It is traveling on a bearing of 060 degrees. Now we always put north from our start point, which is town A, and bearings are measured clockwise from north. So this angle in here is 60 degrees. Now we're asked how far east has it traveled during this time. Now we know east is to the right and horizontally, so we're trying to find this distance x, which is the distance how far east it travels as it goes from A to B. Right, now this becomes a trigonometry problem. So let's get into labeling sides. We want to find out the opposite, and we know the hypotenuse, so we're going to use the sine ratio. We have an angle of 60 degrees, so let's replace the bottom box with sine of 60. We're trying to figure out the opposite, so let's replace that with the x, and we know the hypotenuse is 130. And since both of these are on the bottom of our triangle, we're going to multiply, and so therefore, to work out the distance of x, we go sine 60 multiplied by 130, giving us an answer of 112.6 kilometers. I've rounded it to one decimal place, so we know the distance in the east direction is 112.6 kilometers. All right, let's move on to example 2. A plane travels 200 kilometers between town A and town B. During this time, it travels 100 kilometers east and 173.2 kilometers south. What bearing did the plane travel on? So let's again draw a diagram to help visualize what's going on. Here's town A, and we're going to go 100 kilometers to the east, and from then we're going to go 173.2 kilometers south. Now keep in mind the plane didn't travel to the east and south. The plane traveled directly in a straight line from town A to town B. Right, we know this angle in here is right angle because we know between north, east, south and west, each of those points there's a 90-degree angle. I'm going to add in the north at town A because that's our start point. That's where we add in our north direction straight up the page. And the bearing we're trying to figure out in this problem is clockwise from north, which is this entire angle around here. Now, if I add back in the triangle, you will hopefully then be able to see that this angle here is also a right angle because there's 90 degrees between north and east. Now, if that's 90 degrees, the only part we need to figure out, the only angle we need to figure out is this angle here called x. And then we're just going to plus it to the 90 degrees to get our bearing. All right, well, let's add in the numbers again, and let's now solve this trigonometry problem. We've actually got all three sides, so you could actually use any of the ratios, but I'm going to choose to use the ratio of O and A, and therefore I'm going to use the tan ratio, and we know the opposite's 173.2, and we know the adjacent's 100, and because we're finding an angle, we're going to go tan minus 1, the inverse of tan of 173.2 divided by 100, and we're going to get an angle which I'm going to, look at that, 59.999, I'm going to round it to 60 degrees. So we've now figured out that this angle X here in the diagram is 60 degrees. So if I go back and pop in the north again at town A, and we know that angle's 90, I hope you then can see that the total bearing we're after is 90 plus the 60, giving us a bearing of 150 degrees. It's got 3 digits, so I don't need to pop a 0 at the front. So the bearing it travelled on was 150 degrees.